Okay, we're going to get started. Here's the sign-in sheet. Is Matt's here, right? Okay. Is this yours or is that Jen's?
No.
I can't. I get all confused. I'm sorry. Okay, today we're on 14, right? I think. Okay. So today we're doing 14. Wednesday we'll do 15. Then next week we don't have class, but you should attend the Necropolis City of the Dead lecture that Miss Bennett's giving. That'll be Monday at 11:30 on the East Campus at Wolf Recital Hall. It will be recorded if you have work or something, or some other class. All architecture classes are canceled, but if you have like a class in another department, you know. She doesn't want us to have class all week because she wants you to attend this lecture and then participate in the design charrette. So the lecture is Monday, a week from today, at 11:30 at Wolf Recital Hall. I'll be there and I'll take attendance. If you can't be there for some reason, let me know. And then I hope you would watch it online or something. I'll leave this here. And there should be some posters up in the hall this week. Can anybody not go to that at 11:30?
I'm not sure yet.
Okay.
Next week.
Yeah, a week from today. No, it's at 11:30. It'll probably last hour and a half on the East Campus. But so I mean, next week will be a good chance for you to get caught up if you're behind. I can't have class Wednesday either because she won't let me. So, but no, we're not going to have this class. But because she wants the whole department to work on this design charrette, and then they're going to a design charrette is like a design project. She wants you to divide into teams and do a project and then present it at the art walk at the end of the week. It's to help bring recognition to that there is architecture here at Del Mar, and you know, let the people of the city know, and just kind of a break in the semester. But
So when are we going to have our quizzes? 13 to 16?
that will be, we'll do chapter 16 the following Monday,
Okay.
and then we'll have the exam on that Wednesday the 6th. So you just have kind of a week off from me. But I will take attendance for that lecture, and that'll be and if you can't come for work or another class, bring me some sort of excuse about that. Okay? Now, for chapter 14, we're continuing into concrete. So this is talking about concrete slabs on grade, which is, you know, pouring the concrete in place. Here's some good details you could copy for extra credit, showing how a slab on grade is made. This is a section detail, meaning it's cutting through the wall vertically down into the ground. And in it you see you have some concrete block here with some reinforcing bars. You have insulation on the outside. You have your concrete foundation wall there. This symbol is the dirt or earth, like a parquet pattern. Usually above the earth you will have 4 inches of gravel. What that does is allow any excess water to drain down away from the slab. Then you have your 4-inch concrete slab on grade that has the welded wire mesh inside. And then you have your flooring on top of that. So this is an exterior foundation wall. This is an interior footing. It's a little shallower, but it supports an interior wall. There's also suspended structural concrete slabs. This is another detail. This is probably similar to what we're standing on right here. You have a concrete masonry exterior wall. You have some steel trusses that are holding up this floor. Then you have that metal, corrugated metal concrete deck that you've seen pictures of before. And then on that is a lightweight concrete flooring with some welded wire mesh in that. And see, that's held up by a steel beam that's clipped to that column beyond. The sign-in sheet's up here for those that just came in. So these are good details to study and to redraw for extra credit. So, and this slideshow is online, so and plus those details are probably in the book. So when you pour a slab on grade, you have to really prepare your site well. That's probably one of the most important factors, is to you actually have to dig out the existing dirt and then put in good dirt that's stable, that won't shrink and swell, and then tamp it down, and then prepare for your concrete. Because if you just go out and pour on whatever's there's no telling what's underneath. It'll cave in, or it'll crack, shrink, and swell. So you really have to prepare the subdirt. And the engineer will usually test the soil and tell you what you need to add. There's the rock I was just talking about a minute ago. That's the 4-inch layer of gravel right here. So there it is right there. And obviously that's a big piece of concrete they're fixing to lay. And there's the waterproofing membrane is what that is over there. Here they're just doing a driveway. You can see though that they do have some rock underneath it, and then they've got some rebar going across. And they've got forms. You know, you have to have forms. We studied forms the other day too, I think, to hold in the concrete. When you have edges on your slabs, or if they're running into another wall or building, you have to allow for some movement. So you need some expansion joint material. Usually that's some form of foam or rubber. And then on top of it, you'll have a sealant that will keep, hopefully, most stuff from falling down in there. You can see that's what it looks like. This is that cut looking down on that column. There's the column, and there's this expansion joint material around it. And then when the concrete's poured, they'll put a sealant over that, which is this right here. Then you have a moisture barrier, which again is just another protection for moisture. You know, it's hard to find pieces of plastic or this material so big, so you have to seal the joints in that, and it's got to be done precisely. So that depending on how much, you know, whether it's just vapor or actual moisture, you know, depending on the level that you need, is how you will seal it. You also got to seal your penetrations. This is a pipe coming through, so they have a special thing they put around where there's going to be penetrations, and helps to seal it off, keep stuff from getting in or out. Here's a picture of the welded wire fabric that's typically in driveways or thin slabs and sidewalks and stuff. That's instead of rebar. Well, there's a little pieces of rebar there, but because that looks like, see how that goes down a little, that's a little like a little beam, but then the 4-inch thickness has just the welded wire fabric. And these little things here are chairs, what they call chairs, so that it sits up in the middle. Here they're pouring the concrete. Again, I told you, I think last week, you know, you want to pour it as close as you can to where it's going to be, so that you know, it doesn't segregate. Here the dump truck is pouring it close to the driveway. Then you got to strike it off or screed it. In this case, they're just using a board because this is a small application. Notice they have a bulge of concrete in front of that to keeps filling in any air pockets there might be. Then you got to float it. That helps consolidate it further. This is called a bull float, what he's using. In larger slabs, you'll have a mechanical type float. Then you got a Darby to float areas of the slab that you can't reach with the long arm. Then you want to finish your edge. You don't want your edge to look like that. You want it to be nice and smooth, so you come along with a tool to finish it in whatever shape you want. Here's a mechanical floating machine. See, it doesn't take long for you to be able to just stand on it. I mean, this is only a couple hours old, this concrete. So that it's really they've got to work fast to get all the finishing done, but before it sets up too hard. Troweling for a smoother finish is used sometimes. Then like on sidewalks and driveways where you don't want to slip, you'll have a broom finish, and that's what it is. You just strike a broom across it. There's also other things you can put on there to add mixtures or things if you need different finishes. Curing, remember it took like 28 days for it to reach the maximum level. We saw that last week. So to cure it to it also has to be kept damp. It has to be kept not too cold and not too hot. So here they're covering the slab to keep it maybe to keep it from evaporating or even keep rain off of it. You want to control your cracking just like expansion joints in walls. So usually you'll have see where they didn't control it very well here. They needed to have more of these little joints so that the crack would be more controlled. So it's control joints like here. And that's just running like a 1/2 inch groove down the concrete. It's not all the way through. See, they should have expanded that joint. They should have kept going because the crack kept going. And it tells you the rule of thumb here. Control joints, which don't go all the way through, it's just a little groove, should be spaced 24 to 30 times the depth of the slab. So if you have a 4-inch slab, it would be 24 times 4, almost 100 inches apart, 98 or 96 inches apart, which is 8 feet at least. This is an expansion joint. It goes all the way through, and that allows for movement in the concrete. It has that rubber around it, and then it's got this material on top. So then we get to casting a concrete wall. First, you're going to have your footing. You can see a diagram over here. Remember, this is a footing is not a foundation wall. It's inside. Way back at the beginning of the slideshow, you saw the footing. Let me see if I can find that. Oh, it's not going to go back. Never mind. So they have the rebar that's coming up that they placed in the footing when they poured it, and then they'll tie it into the wall that's going to be on top of that. Here you can see this is a detail of that. You've got some bars on the bottom going both ways. That's coming towards you. That's going parallel. Then it's tied to these bars that stick up into the wall. That's this right here. Can you see that? Then the wall itself has bars in it that will tie. So all of this, once it's done, will be, a solid piece of concrete. So here they're designing this wall for shear, which is lateral forces such as wind or earthquake to keep it from sliding against one another. There's going to be more shear force on either end. So that's why there's more bars on either end, and then this is, it thins out in the middle. Here's some shear walls for a high rise. This is the bottom floor. Lots of steel in that. And this is when you got to be careful. Last week we discussed the aggregate, and your aggregate has to be able to fall down between these bars when they pour the concrete. So it can only be a certain size. Here you got forms. This is looking down inside that wall, and these are form ties that will basically hold these two pieces of wood together while the concrete's so wet and heavy. Also, one thing to remember is that your concrete's going to look like your formwork when you take the formwork off. So, if you don't care what it looks like, if it's going to be not ever seen, you don't have to have too much care. But if it's going to be an exposed concrete wall, you want nice, smooth formwork, because when you take that off, you'll see the wood grains. Sometimes you want that, sometimes you don't. So it's important to understand what the concrete's going to look like once you take that off. There's just another look at the form ties. They can tighten these up and clip these on the outside. That's what it looks like after you take the formwork off. See how that fell off? Then you got this little hole that you can fill with putty or little patchwork if you're going to cover that wall with something stucco or something. Here they've filled it. You can see the broken end of the metal. But see how the concrete will pick up every little scratch and indentation on that formwork. So you want it to be nice. You want it to look like what you want it to look like. Okay, this is another wall form. It's got whalers on it. That's what these are right here, these horizontal pieces. Then you got the panels. Then you've got bracing to hold that up because it's very heavy when they pour it in there. So they got to have a lot of formwork. Is the most expensive part of concrete, is getting the formwork right. Here's another type of formwork that will keep climbing up the wall as they pour it. This is going to be probably a multi-story wall, and they can just keep jacking it up. They'll pour like 4 or 5 feet, let it cure, then crank that up, and then pour another 4 or 5 feet. See how heavily this is braced for this tall wall. There's another form of self-climbing formwork as they build this. Probably this is an inside structure of a high-rise that has to be, go the whole height of the building. So even when, remember when you saw the slab pouring last week and they had the vibrators, you have to do that in a wall too, because you don't want any pockets of bad concrete down below. So, they have to finish it off, similar to what they do on a flat slab, and make sure it's all solid and, nothing weak, and everything fills in. Here you can see after they took off the formwork, you can see everything that was there. Sometimes that's okay, sometimes it's not, depending if you're going to cover it with stucco or brick or whatever. Sometimes you want to see a wood pattern. You can design your formwork and then take it off and your concrete looks like wood and you paint it. So there's another example of what it looks like. And they have these block outs for probably ductwork or electrical wires here. Here's a good example. You can see the wood. They wanted this wood look, so they use small pieces of wood horizontally for their formwork, and then when they take it off, it looks like wood, but it's a whole lot stronger. Here they didn't do such a good job vibrating it so it all filled in, because you can see a big, that's not right. And depending on, like I said, whether it's going to be exposed, or if this is really bad, the structural engineer may say tear it down, do it again, because that's going to affect the structure of the building. I don't think this necessarily would. That's more cosmetic, but sometimes it can. Like that, that's not good. The engineer would probably say, saw that out and re-pour that little section, make it smooth. And here again, they want to control the cracking. So you need some vertical control joints, 24 to 30 times the thickness of the wall. You also need full depth expansion joints every so often. You can see this is a retaining wall, which basically a retaining wall holds dirt on the other side. So the moisture from that dirt is coming through these little tiny cracks. This is a new material that more and more people are starting to use called ICF. It's basically styrofoam concrete blocks, and then they come in and fill it with concrete. It has very good insulating value, and if you use it on houses, I mean, you'll want to try to get most of your plumbing in the beginning, but you can groove out this styrofoam and run wires and things like that after you've poured the wall. So. And this is, there's several houses like this out on the island that are recently built, and it helps, you know, it's very good for hurricanes, stuff like that. Those houses will be there when the rest are blown away.
There's a condo out there, in the gated community. I don't know what street it was on, but it's built like this.
Oh yeah? A condo or a house?
It's a complex, it's a condominium.
Oh, and the whole complex is that way.
The complex is built like this.
Huh. Here's tilt-up construction. It's tilted up, hence the name. They pour it flat. You can see it's easier to pour concrete on a flat surface. You obviously have less form work involved because you pour your bottom slab and that's already a form. Then you can just pour this, and then when it's cured, you tilt it up. It's a pretty economical way to go for certain types of buildings. So columns, which are, a big part of skyscrapers. Columns may rest on isolated footings, pile caps, which we studied way back in the first class, caissons and large portions of strip footings. This is the lower layer of a reinforcing has been placed for this isolated footing where they're going to be putting a column. Here's kind of what a column reinforcing looks like. You can do it, square or circular. Doesn't look, the outside of the column is not going to look any different. Just depends what the engineer wants. So you got your main bars going up, whatever they call for, and then they got your ties that hold them together until it's all said and done. Or you can do a circular pattern with spiral ties. Here's some details looking down and different types of patterns you could use for reinforcing. Different numbers of bars. There's a lot of metal. You're going to have some small aggregate to be able to fall down through that. And you can notice that as it goes up, the vertical bars are bent inward so that the next section can be nested with that, and it won't, the dimension won't change on the outside. Here's some prefab reinforcing that it was done in a shop and delivered to the site, and then they'll just, probably easier to do that kind of work in a shop if you can, than just connect it all together at the site. So you can see how the bars are bent inward there so that they can nest easier. Column forms, same thing. Your column's going to look like your form. So depending on how you want it to look, your form work needs to be pristine, or it can be sloppy if you're not going to see it, I guess. Then they take the concrete in a bucket and they drop it in there as close to the position as possible. You don't want to drop it, too far, or you get the segregation problem. There it is after they take off the first layer of formwork. And then they'll add some more up there when they get ready to go higher. So this, this is a different types of slabs, and it's It's kind of important to understand this, and it talks about it in detail in the book. One-way solid slab, the slab is reinforced to span one direction only. The girders, which are the deepest beams, which would be these, span between the columns. So you've got columns, then the girders rest on the columns, then the beams, these are the beams right here, they rest on the girders, and then the slab is poured between the beams. So the slab is relatively thin. And this is called a one-way solid slab. All of this is, it's not necessarily poured at the same time, but it's interconnected with its reinforcing. So the one way is you got your columns, girders, and then the beams, and then the slab. And the reinforcing in the slab will primarily run from beam to beam. That's why it's one way, because it's going to be going that way. Here's a look at it, kind of a cut through looking from above. You can see the reinforcing, like I said, is running from beam to beam. The beams rest on the girders rest on the columns. And then we have a rib slab, which is a one-way concrete joist rib slab. You have a system of beams and slender, closely spaced ribs support a one-way slab. So here you have columns and beams and then ribs. Here's an example of one being poured. These are going to be your beams right there, and this is formwork for the ribs. It's like big plastic things, and it's got the ribs built into it. Here's a wide module concrete joist system, like one-way joist, but ribs are spaced a little bit further apart, and because of that you need a thicker slab. It's also called the skip joist because kind of like you're skipping. On the other one they were about twice as much. So from one way you go to two-way. Two-way means that the reinforcing will run both ways. Two-way framing systems, a two-way slab is reinforced so that it spans structurally in both directions. Two-way slabs are more structurally efficient than one-way slabs of the same thickness. Two-way slabs must span roughly the same distance in both directions. As the layout of the slab supports become increasingly rectangular, the proportions of efficiency of a two-way slab decrease. So two-way slabs are better if they're more square. They're a little bit more efficient. And you see that a lot in parking lots, parking garages. That's a two-way system. Here you can see it, it's kind of square. You've got your columns and your beams are evenly spaced, and then your slab is on top of that. You got a two-way flat slab, which has a reinforcing slab, is supported by columns without beams, but the tops of the columns are kind of mushroomed out to support, and there's a lot of reinforcing, which I think you'll see in a second, over this area, and then it thins out in this area. Yes, you can see it there. So this is the mushroom out part. There's a lot of reinforcing in the slab, which would takes the place of those beams before. So you can, and then there's not as much there. There's a parking garage. Two-way flat plate. Supports by columns without beams. There are no column capitals or drop panels in the flat plate system. Additional reinforcing within the depth of the slab and the column slab junction is used to increase strength in that area. Flat plate systems are best suited to light loads than flat slab systems. So this might just be a roof or something, something that nobody's really going to be driving or walking on. Here they're reinforcing, getting ready to reinforce a two-way flat plate system. You've got these are called studs that increase the strength, and then you've got the green cables are going to be post-tensioning. They're going to pull those real tight when the concrete, after they pour the concrete, and then after it's cured, they're going to cut them off and they're going to kind of like spring back into place, and that makes the whole thing very rigid. Here they're doing a two-way flat plate system. Again, this is probably, condos might be a good use for this, or where there's not a lot of, you don't need much, it's not concentrated heavy loads. Two-way waffle slab, looks like a waffle. Kind of got the little mini ribs all in there. Instead, it's like it says here, similar to the one-way joist, but with two ways. So you got joists going both ways, and then at the columns, you'll fill that in solid. Here you can see a parking garage with that. These are all solid, and then it thins out over there. It's a two-way waffle slab. Okay, so that's, any questions on the chapter 14? Lovely, lovely concrete. Okay, I want to talk about right now, and this is something you can work on next week too, is the final project. I'm one to believe that you should never wait till the last minute. So I like to give these things out early. And we'll go over this. The final project counts for a test grade. It'll be due the last day of class, and you will present it. Do you want one for your brother? Okay, so I'm going to go over this in depth just so there's no misunderstandings. You can ask me questions. The culminating project for the semester consists of drawing a construction assembly in AutoCAD, if you're familiar with that, or by hand. Everybody's got to do their own projects. It's not a group work. The assembly must be presented in a final presentation drawing, meaning I want it to be neat, not just on torn out notebook paper. I want it, like a report. Final presentation drawing and accompanied by a 2-page report, double-spaced, describing the construction assembly. The assembly may be of your choosing. For instance, I want you to draw, you can do a wood frame construction, a section of a wall section of a wood frame construction house. You can do concrete block. You can do heavy timber. Anything that we've studied, that interests you. So you're going to really study that type of construction and how it goes together, and your report will describe to me all the bits and pieces of your wall and why they're there. Like the why it may have a vapor retarder, why the brick is here, why there's a finish on the inside. So you need to choose that. It's worth 1 test grade, like I said a minute ago. Your choice of assembly is due Wednesday, or if you already know, you can do it today. And that's in here. There's a piece of paper right here. You'll give back to me, stating that you understand what you have to do, and your wall section choice or your wall assembly choice is blah, 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 and you'll sign it. And that's worth a homework grade. The final projects are due on our last class day, which is Wednesday, December 4th, and will be presented in class that day. So you'll stand up and just give like 5 minutes. This is what I did, blah, blah, blah. There's many examples of wall sections throughout the book. I say page 146 has one, and I've included 2 samples. This is a wood frame construction. This is a kind of, similar to what I want to see. I want to see the whole wall, foundation to roof, and then what's all involved with it. And then here's another, this is a commercial structure which has brick and metal, that's pretty involved, but if you want to get that involved, you can. It shows all, it has notes of all the materials. It has heights, dimensioning, stuff like that. Let's see what else. Here's a better picture of that wood section. If it's you don't necessarily have to have 2 floors. It might just be 1 floor. But it shows, pretty much everything involved in that. And I would, in addition to what's here, I would want some vertical dimensions on here. There's the other one. See, this one has the dimensions of where, like the top of the slab, if you have a window, where the window is, the top, where the ceiling might be, where the roof starts. Okay, that's that. Is there any questions on that?
What is the last day of class? Do you know the date?
It's Wednesday, December 4th. And then we have a final the following week, which I think is on Monday the 9th, the last time I looked at the schedule. Last time, and I might do this time, it might be a take-home final or an online final where you don't really have to come that day. But it would be due by that day. So, I don't know if I put this on here. On my schedule, I don't think I put it on there. On Monday, November 25th. Did I put that on here? You need to write this down because I didn't. Monday, November 25th, I want to see a draft of your final project, just so that I know you're not totally waiting until the last minute. Yeah. Yes, it's on your syllabus schedule, and it's probably on Canvas. It's on this sheet of paper. But some more of these. Is there any questions? Anybody know what they want to do yet? You already got it? Okay. I don't have any, thank you. I don't have any concrete homework. Hate to let you go so early. I mean, y'all can work on your review, or let me hand these back that I have. Any more extra? Well, I think the extra credits were already due. Elijah? Thomas? Caleb? Marcelina? Josh? Fred Espinoza. I already gave you yours back, right? I think.
Yeah.
I guess that's it. If you don't have any questions, I'll see y'all Wednesday. Got a question? Or?
I wasn't sure what to do. I guess what we're doing, like here, is basically drawing one of these, but to scale.
Yes. You're going to pick a wall type. Let me turn this recording off.
How big would be anything off your book?
Any wall